Hi, hello, welcome to Dr. Zakir Math. Today in this video, we are going to solve exercise P1. This is the first exercise in the module 1. Let's begin. While you are watching this video, please divide the screen into two parts. One side the video will run and another side you just open a PDF, and this PDF I will upload it in the first comment or in the description box. So you can download it and you can start working on this PDF, right? Which is a Google Drive link, right? So, okay, let's start. So what are the things we are going to study in the first lesson? The first things we are going to study is natural numbers, whole numbers, integers, and irrational numbers. Again, I'm telling, already you studied this in Arabic mode. We are learning now in English mode. What are the things we are going to study? First one is natural numbers, whole numbers, integers, and rational numbers. Again, I'm telling, natural numbers, whole numbers, integers, rational and irrational. What is a natural number? A number starts from 1, 2, 3, 4. Okay, right. That means what? 1, 2, 3, 4, up to infinity. These numbers are called natural numbers. The next number we are going to study is what? Whole numbers. So natural number plus 0. Look at here. There is a 0, just I added here. Added means included. Okay. So it means 0, 1, 2, 3 up to infinity. This is called as what? Whole numbers. And both the numbers are not having no decimal. What do you mean by decimal? Decimal means this one, 5.48. So this is called decimal. When you have some point and some numbers are after the point, then it is called decimal. So there is no decimal here and there is no decimal here. So what is natural number? 1, 2, 3, 4, 5, 6, 7, 8, 9 like that. What is whole numbers? 0, 1, 2, 3, 4 like that. Okay. Next we are going to start from integers. What do you mean by integers? Integers means first you write natural numbers. Okay. 1, 2, 3, 4, 5, 6. Then you write whole numbers 0, right? After that all the negative numbers -1, -2, -3 up to negative infinity, and here up to positive infinity. So these numbers are called integers. These numbers are called what? Integers, right? So the notation for integers is Z, notation for whole numbers is W, and the notation for natural numbers is N, right? Yes. Up to these three things, no confusions, because all the time the students are get very clear with this. Natural numbers, okay, 1, 2, 3, 4, 5, 6. What is whole number? 0, 1, 2, 3, 4, 5, 6. Okay, no problem. Integers, just plug in again the negative numbers, -1, -2, -3, -4 like that. So in this way, the first three definitions are very, very clear. Natural numbers, whole numbers, integers. But the next two things are little bit confusing for the students. The first thing is rational numbers. What do you mean by rational numbers? Rational numbers means it is denoted by the letter Q, right? And it can be written in the form of fraction. What do you mean by fraction? Look at here. This is called fraction, right? What is this one? So this is called numerator. This is called denominator. What is this one? In easy way, we call it as up. That this is one called down. Okay. But the correct word is what? Numerator. The up is called numerator. Okay. And the down is called denominator. I know the English is little difficult. It's the beginning of the class. You all came from the school just now. So slowly listen to the words. These words will be recorded in your mind. So denominator means it is down. Okay. Right. So 2 is the numerator and 3 is the denominator. So any number which can be written as the fraction mode, then it is called rational numbers. It is called what? Rational numbers. Not only this is rational numbers, there are some more things also rational numbers. Okay, keep in your mind. I will come to you step by step later. Irrational numbers. It is very, very easy to define these irrational numbers. You can write either I or Q. In some places we write I and some places we write it as what? Q. Right, no problem. Irrational numbers are very clear. Square root of any numbers which is not a perfect square. What do you mean by perfect square? Root 4 is equal to 2. This is called perfect square. Root 9 is equal to 3. This is called a perfect square. Okay, right, like that. So root 2, pi, e and everything is called as what? Irrational numbers. But still it is not clear. I'm going to tell you few more points about this rational numbers and irrational numbers. Just listen. Okay, I have given something more than that. You see here, root 2, I have given root 3, root 5, all these numbers. Okay, right. And then pi, right? Then root 3 is already here. E is an Euler's number. Okay, root 5 is there. So it means what? You have all the square root of 2, square root of 3, square root of 5, square root of 7, square root of 9 will not come. Keep in your mind, square root of 4 will not come. Why? Because this is equal to 3, this is equal to 2. So square root of 10, square root of 11, these are all called irrational numbers. Is this the only one going to be rational number? No. There are some more things. That is pi. Pi is nothing but 3.141592653 and still it's going on. You can check in the calculator, it is still going on. But in the school, the teachers always used to say 3.14 is pi. No, 3.14 is the pi value. But when we talk about their family, it is totally different. So its family is what? Belonging to a big number, which is 3.141592653. So this number is also a irrational number. So, and also the next is E. E also you can find it in the calculator. You can use alpha mode and it is in the down. E is also, it's an irrational number. So, okay teacher, what is the value of E? You can check in the calculator. Just go to the calculator and just press alpha and go down and press equal. E is equal to 2 point, which is already given here. I will write it 2.718281828 and still it goes. Keep in your mind. But the calculator cannot able to give more than 9 decimals. So that is where it stops. But in general, it never stops. It keeps going on. Okay. Now I'll ask you one question. Teacher, if they give you pi, is it an irrational number or it is pi is what? Irrational number. Yes, I agree. Pi is an irrational number. Okay, teacher, if they give pi, it is an irrational number. Suppose in the exam, they give 3.14. Is it an irrational number, teacher? No. Keep in your mind, 3.14 is not equal to pi. So what about this 3.14, teacher? 3.14 is a rational number. How, teacher? 3.14 is a rational number? Yes. Then pi is irrational number you are telling and 3.14 you are not telling? No. Pi is equal to 3.14. It's here. 141592653. So this keeps going. So this is an irrational number. Keep in your mind. So this is what I wanted to say it for you. So keep in your mind, pi is a rational number, but 3.14 is not a irrational number. Okay, teacher. What about 22 by 7, teacher? This also in the school, the teacher told me pi is also equal to 22 by 7. Yes, pi is equal to 22 by 7 by value. Value means what? The amount. But originally it belongs to which group? Originally, it belongs to which group? It belongs to the fraction mode. When it belongs to the fraction mode, it is a rational number. It is what? Rational number. Okay. So what are the situations rational number will come, teacher? So slowly I explain. Okay. Right. What are the situations? For example, sometimes there is a situation comes like this. 0.6, there is a bar. B-A-R, bar. They used to read bar. If the bar comes means decimal repeats forever in pattern. It means, what is the meaning of this? This decimal repeats. What is the meaning? Decimal is going to come again and again forever in pattern. Forever. So what type of number this one? If a bar comes, then keep in your mind, this is an irrational number. This is what? Irrational number. What number is it? It's a irrational number. Okay, right. Hey, sorry. It's a rational number. Sorry. When the bar comes, it's a rational number. Again, I'll reframe the statement. Listen carefully. If the bar comes, it's a rational number. If the bar comes what? Rational number. And again, I'll tell you about 3.14. 3.14 is a rational number. Okay. Why? What's the reason? It stops after some decimals. So that is why it's called rational number. Okay, right. But pi is what? Irrational number. Keep in your mind. Pi is irrational. Okay, teacher. There are some numbers like this. For example, 0.1428571 and then they put dot. What is the meaning of this? Let's see. Look at here. 0.1424857 142,857. Can you see that? The same pattern keeps repeating. If the same pattern keeps repeating, it is a rational number. Keep in your mind. Okay? If the same pattern keeps repeating, same pattern keeps repeating, then it is a rational number. Okay, right. Okay, next, if the decimal, for example, let me take this one, it goes forever. Why it is called rational number, teacher? Because there is a dot, it's going on. Look at the number, it's repeating, right? So 1425871, what can I do? I can write like a bar. So what is the meaning of this? This is 0.6666, it's going on. So there is a bar is there. So if the bar is there, actually it is what? It is a rational number. Okay, right. Okay, let's give another example. Okay, there is no place. I can write it here. Okay, there is a place here. Okay, there is no place. Let me write here. Okay, let me write here. There's a small places here, right? Let me change the color and I will write. Suppose if there is a situation 0.01, for example 011, a 0111 dot. So what is the conclusion? Can you guess this one? Is there any number repeating? 010, 110, 0110? No. There is no number repeating, right? So what do you mean by rational number? I said a rational number has a decimal expansion that either terminates or repeats a fixed block of digits, right? This decimal does not have a fixed repeating pattern, right? It is not repeating. Okay, right. When it is not repeating, keep in your mind, when it is not repeating, right? Because the repetition is not regular. What do you mean by regular? Look here, 1428571, 1428571, right? So like this, it keeps repeating, right? So here there is no repetition in regular, right? So it cannot be expressed as a fraction of integers. That is why this is called irrational numbers. Okay, teacher, can you give me as a rule, what can I do when this situation comes? Okay, right. Look here, everybody. If the bar on the top, if the bar is there like this, if the bar is on the top, then it is a rational number. And there is a number, no repeat. You see here, no repeat. 0.0101110111, there is a no repetition. If there is no repetition, it is an irrational number. Clear, everybody? So these are the things. Also, few things I want to say that never repeats. Keep in your mind. Repeat means it is not coming again and again. So then it is called irrational numbers. Keep in your mind. Never repeats. So all these introductions clear. What do you mean by natural numbers, whole numbers, integers, and rational and irrational numbers? Okay, right. Let's go and solve few questions about this one. Let's go to the first question. Determine which numbers in the set are natural numbers, whole numbers, integers, rational, irrational. What did I say? Natural numbers 1, 2, 3, up to infinity. What did I say? Whole numbers 0, 1, 2, 3, 4 and up to infinity. What did I say? Integers 0, 1, 2, 3 up to infinity. Negative 1, negative 2. All these things are what? Integers. I said integers, right? Yes. Only these two things confusing. Rational and irrational. So first let me tell you what is irrational numbers. Is there any number here repeating or dot dot dot? No. So it means very clear square root, e, okay, pi. These are all irrational numbers. Just keep it in your mind. And let me come to the rational numbers. Rational numbers means we have fractions and decimals. We have fractions and decimals. These are all called what? Rational numbers. What do you mean by fractions? This is called fraction. This is called what? Fraction. What do you mean by decimal? This is called decimal. Okay. This is called decimal. These are all new English words. Keep in your mind. Okay. Right. So let's start the question. Natural numbers. Okay. Which is equal to, right. Let's open a flower bracket. This is called flower bracket. Okay. Natural numbers. Look at this one. Root 5. No. Negative. No. This one. 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 Yes. This one. Yes. So 12 comma 5 is the first one. Whole numbers. What did I say? Whole numbers. You should include 0. So 0, 12 and 5. Right. Integers. What did I say about integers? First of all, you write 0, 12, 5. After that, you can add the numbers. What are they? Minus 7 is a negative number. Minus 7 by 3 will come? No. Because fractions will go to rational numbers. And then 3.14 will come? No. Integers means what? Only whole numbers with positive and negative. So this will not come. This will not come and this will come. Minus 3 will come. Okay, right. So minus 7, minus 3, 0, 5 and 12. Right. Rational numbers. Everything I have to include. Okay. And this minus 7 will come. Minus 7 by 3 will come. 0 will come. 3.14 will come. 5 by 4 will come. Minus 3 will come. 12 will come and 5 will come. This is rational numbers. Irrational numbers, very, very simple, which is there is only one square root is there, which is not a perfect square. So irrational numbers is just square root of 5. Okay. Why it is not a perfect square, teacher? I told you already, perfect square means you should get a whole number. This is root 9. You should get a whole number. This is called perfect square. Okay, perfect square, right? But root 5 is not a perfect square because this value is equal to, root 5 value is equal to how much? 2.236067977 something, I don't know, which is 79 some. This is irrational numbers. How can you say it's irrational number, teacher? See here, there is no same pattern repeating. Same pattern, same style is not repeating. 2, 3, after that 606, 7977. Is there anything same number repeating, same pattern? No. So in this way also you can say it is an irrational number. Clear all of you the first question? Natural numbers, whole numbers, integers, rational numbers and irrational numbers. Right. Let's go to the next question. Determine which numbers in the set are natural numbers, whole numbers, integers, rational numbers, irrational numbers. Natural numbers means what? 1, 2, 3, 4, 5 natural numbers. Whole numbers means what? 0, 1, 2, 3 whole numbers. Integers means what? 0, 1, 2, 3 dot 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 and minus 1, minus 2 dot 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 like that. These are the two numbers which is having a little confusions, right? Yes. Now first we pick up the irrational numbers, okay? Irrational numbers, what did I say? Which is pi, square root, e. These are all irrational numbers I said, okay? Right. Also some numbers which is having dot 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 without same pattern. Dot 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 without same pattern. If there is no same pattern, then it is called what? Irrational numbers. Without same pattern. Same pattern means same design. What do you mean by same design? Let me show you the design. Look here. This is the same design. 4, 2, 8, 5, 7, 1 like that. Okay, right. So let's do this question. Okay, right. Let's start this question. First, we write irrational numbers. Okay, so what are the irrational numbers we have here? Pi by 3. Okay, this is an irrational number. Let us write first this one. And then square root of 2 is an irrational number. Let us write this number square root of 2. And what about this one, square root of 9? It's a perfect square. This is equal to 3. This will not come here. Keep in your mind. Okay. And this is 3e is also an irrational number. Right? Very easy. Okay. Let's go to the next one. Natural numbers. Okay. What are the natural numbers? Minus 9 will not come. Minus 7 by 2 will not come. Pi by 3. Okay. 5 will come. Right? After that, this is a fraction. This is a square root. And this is a non-terminating. We can say this 0. This is 1. So 5, 1 will come. Then 2 will come. Okay. Right. Next, what is the whole numbers? There is a 0 here. We are going to include the 0. So we have 0, we have 5, 1, 2 is the whole numbers. Let's start the integers. Integers means what? Same numbers with negative, right? So you will get what? Minus 9, right? Minus 9, you will get this won't come. And then 5, and the next is 0, the next is 1. Then minus 4, minus 11. Okay. So, and I missed 2. Yes, I think I missed 2. 1. After that, 2 I missed. And then any other number? No. Okay, right. So, minus 9, minus 5, 0, 1, 2, minus 4, and then minus 11. Okay, next we go for rational numbers. What is rational numbers? Little bit be careful. Rational numbers. Okay, let me slowly move this one. Right. So what are the rational numbers? So many things are there. Minus 9, minus 7 by 2, and then pi by 3 won't come. 5, and then 2 by 3, square root won't come. And 0.26 because it keeps running. Bar is there. And then 0 will come, and then 1 will come, right? And I made a mistake. Square root of 9, I missed it from the beginning, right? So square root of 9 I have to write, which is equal to 3. Here also square root of 9 I have to write it. Here also square root of 9 I have to write it. Okay, let me write here square root of 9 and then bracket. And then 1, after that square root of 9. Okay, because square root of 9 is equal to what? 3. So 0, 1, square root of 9, minus 4, and then 2, and then minus 11, and then 0.127. So much of numbers, right? So all these things are just called it as what? The rational numbers. All these things are called what? Rational numbers. Okay, right. So now in this way, we learned two things. We learned two questions. What are they? So we learned how to determine natural numbers, whole numbers, integers, rational and irrational numbers. Okay, everybody, right? Is it clear? So if any question is given, can you identify? Okay, just a minute. I'm going to give you one question for your practice. So this is your practice question. So please solve this question and write the solution in the comment box. Okay, right. So this is the first part of the P1 exercise because the video will go for lengthy. So that's why I'm going to stop it over here. Make sure to practice the examples we covered today and review our notes before moving on. If you found this lesson helpful, please like the video, subscribe and share it with your classmates so they can benefit too. In the next part, we will move to the next type of questions in this P1 exercise. See you there. So East or West, Dr. Zahid Math YouTube channel is the best. Take care all of you. Bye bye.